Let's continue from previous sites. Now we look at construction project and requirements. A project requires clear and coordinated documentation to ensure successful planning, execution, and management. At the foundation of modern construction project is BIM, or BIM Execution Plan. This plan is fundamental task that sets instruction for applying BIM principles to the specific project. It defines how BIM will be implemented, guiding all participants in how to use digital building model through the project life cycle. Moving into project documentation, specifications play a key role. Specifications are detailed description of the parameters and characteristics for all equipment, building materials, or products used in the project. This includes elements used in landscaping such as plants, materials, and saplings. It's important to note that, however, the specifications do not list the quantities required, only the detailed qualities and the standards expected for each item. For managing quantities, two crucial documents are used: the Bill of Materials and Bill of Quantities. The Bill of Materials of BOM is estimating and document that lists the quantities for all equipment, materials, and products, including landscaping components needed for the project. This document helps with material procurement and cost estimation. Bill of Quantities, or BOQ, is a comprehensive document used for procurement and project administration. It details all construction works by work type and crucial information, cost, and so on. The BOQ is essential for transparent bidding and controlling project expenses during the execution. Accurate measurement is also foundation in construction documentation. Area measurement quantifies a surface or its part using the appropriate units of area. This might include measurements room area, structure area, net, cross, floor areas, and so on. In construction terminology, the term area and surface have distinct meaning and should not be confused. Construction projects must also operate within the strong regulatory framework. Legislation and regulation refers to binding legal instruments such as laws, decrees, and decisions issued by the authorities. While it is mandatory to follow this regulation, it is not required to list every relevant legal act in the project-based documentation, as a compliance is already a universal obligation. Finally, codes of practice provide rules, guidance, or characteristics required for practical activities of the results. These codes include standards, technical specification, and regulation. In the construction project documentation, it is often necessary to list which codes of practicals are being followed, especially when several options are available. In some cases, compliance with certain codes or standards is mandated by the legislation, such as harmonized EU standards for product and design. These documents and measurements are utilized for various applications, including design and planning using the BIM plan, cost estimation through the Bill of Quantities and Bill of Materials, procurement and bidding, administration, control, and project works. When correctly preparing and coordinating these essential construction documents, ensure clarity, legal compliance, and efficient project delivery from start to finish. A construction project begins with clear definition of the term surface. In this context, the surface is the set of points forming the outer layer of the object, separating it from the surrounding spaces. It is important to note that surface and surface area are not synonyms. While a surface has an area, these terms aren't used interchangeably in construction vocabulary. Every construction project functions are a unified, complete information system. The project itself describes either an entire building or part of the build, or another object created by the designer. For effective planning and assessment, all documents and information related to the project must be gathered and used together as a single whole. Standard set of recommendation framework for the minimum level of the information and detailed requirements at each design stage of the construction project. The type of design tool used, such as a pencil and paper or digital tool like BIM, doesn't affect the required project content or level of detail. Both traditional and digital outputs are evaluated using the same definition for each specific project stage, regardless of whether the digital version provides more information. Requirements for the final format and submission, whether digital or paper, are determined by the client instruction and legal regulation. To ensure success, the compliant building must comply with all legal requirements. This exact division and responsibilities, boundaries, and roles for each designer involved is specified in project contracts and according to the needs of each individual project. However, the standard does not define the responsibilities within absolute precision. Rather, it provides flexibility so agreement can be tailored to each project circumstance. Lastly, architectural project solutions included in the construction project are protected by copyright law. This ensures that the creative work and intellectual property of designers are legally recognized and safeguarded. The process of designing a construction project is divided in 3 interconnected stages: preliminary design, main design, and working design. Each stage builds on the previous one with an increasing detail and precision to provide and complete an effective construction solution. The preliminary design, known as e-õppevara, is the first phase. It begins with the design brief prepared by the client and often includes sketches or initial concept from the architecture, engineering, or technology fields. The main goal at this point is to evaluate alternative solutions and select a general approach that best suits the client's requirements. This phase also considers input from the public authorities and other stakeholders, ensuring that the proposed solution can be accepted by everyone involved. The chosen solution, along with its core principles and desired quality levels, is documented and then a phase concluded when the client approves the preliminary design. After approval, the project moves into main design stage of e-õppevara. Here, the initial solution from the preliminary design are detailed further. This stage provides the necessary information to estimate construction cost and creates the main documentation for construction tenders or bids. This main design ensures all chosen solutions are specific and sufficient details and quality for contractors to prepare accurate construction offers. The outcome of this phase is a comprehensive set of documentation used for procurement and cost determination. The final stage, called working design or e-õppevara, is the most detailed phase of the form, the direct basics for actual construction work. At this point, all necessary construction drawings, technical details, and specifications are completed, making the information suitable for use on site by buildings. Unlikely the earlier stages, which are not sufficient for construction alone, the working design includes everything needed to start building. This is important to note that some projects, especially smaller ones, it might not always be necessary or efficient to create full preliminary and main design documentation. However, producing these stages as a separate documents can help reduce client risk and ensure different process of the construction project in parallel. In summary, the construction design process is structured to move from broad concepts in the preliminary design to the refined and developed plans in the main design, and finally action-ready documentation in the working design. Each stage serves a specific purpose and ensures the quality, feasibility, and smooth execution of the construction project. The building project design process is divided into several key stages to ensure that construction runs smoothly, within each stage adding more detail and precision. The process starts with the preliminary project called e-õppevara in Estonia. This is initial concept phase where the basic ideas required are outlined and approved by the client. Once the preliminary project is confirmed, the next step is main project, e-õppevara. The main stages begin with the client approach, preliminary project, and detailed design brief. The objective at this stage is to define all complex design solutions in the way that they work together and are complemented with each other. The details must be accurate enough that all process solutions can be successfully executed alongside each other, without causing conflicts or unintentional cost increase. This is crucial that technical solutions at this stage are coordinated, but it is not necessary for the level of detail to match of the working project. Important, the main project should specify equipment and materials by the technical parameters rather than the specific brands or models. This approach protects open competition during the bidding process. If reference products are mentioned, the criteria that make them suitable for the project must also be specified, including both technical and aesthetic factors. After the main project has been approved by the client, the working project or the project starts. The working project is focused on providing the detailed specification and instructions required for direct use of the construction site. At this stage, solution outlined in the previous phase are refined to a level of detail necessary to actual construction. This includes specific extract brands and models to building materials and equipment. If the construction cortex has been already selected, if not, the designer selects suitable product together with the client. The working project assumes that the construction work will be carried out by the trained professional under competent supervision. Here, all instruction and design components must be coordinated and free from constrictions. The aim is to prevent construction issues, ensure everything fits within allowed tolerance, and minimize the need for changes during the building. The working project is judged successfully if its instructions are so clear and complex that no further documentation correction are needed during the construction, as long as everything remains within standard tolerance. It is recognized that in certain cases like renovation or reconstruction, not every detail can be finalized in advance, and some design elements need to be further defined during the construction phases. In those solutions, any necessary clarification must be highlighted along with the reasons. A key difference between the main project and the working project is their details. The main project uses technical parameters, while the working project specifies actual brands and the models when appropriate. The main project is prepared before the tender or contractor selected, supervising fair competition, while the working project is ready for direct construction. The documentation from both stages must serve as a solid basis for the construction activities and supervision, often using recognized standards and markings for typical materials. Overall, these clear stages and responsibilities aim to avoid cost, error, and ensure the construction process is efficient and reliable as possible. The construction project design process is divided into three main stages, each building upon the last. Integrated design supervision throughout. Stage 1 is conceptual design and sketching. Here the initial project idea and requirements are gathered, site analysis performed, understand the context and limitation. Designers prepare preliminary layouts exploring different solutions and produce early sketch level cost estimation. This phase turns into data such as owner requirements and basic site information into foundation sketch plan. Stage 2 is construction project documentation. This is broken down into substations: the preliminary project, the main project, and the working project. The preliminary project, or the PP, develops the overall solution, defined both on the functional and technical requirements. Once the general approach is set, the main project on EP detail the technical aspects, including structural and map or mechanical, electrical, and plumbing systems design. Finally, the working project of EP translates these designs into site instruction and provides specific bills, quantities, and cost estimation. Stage 3 is designer supervision and monitoring. During the construction, designer conduct regular site visits, verifying the work companies within the design. They address on-site changes and ensures that all materials and installation meet the specific standards. If technical issues arise, they assist with problem solving, helping to keep the project on track and with requirements. The overall process flow demonstrates how various inputs such as owners' requirements, site service and regulatory codes, and budgets feeds into design phases, starting with the preliminary project and progressing to the main and working project. Each phase produces outputs such as permit application, technical drawings, specification, and reports, which are essential for moving to the project. Once the documentation and approvals are complete, construction starts, always underpinned by the ongoing designer supervision to maintain quality and resolve any issues that might arise. This structured approach ensures that every construction project moves systematically from initial concept through the detailed design to construction and successful completion. The building design process relies on the collaboration between experts from different engineering and design fields. Each project brings together specialists in areas such as architecture, structural engineering, HVAC, automation, and others, who create solutions with their area of expertise. These solutions are compiled into specific project parts. The way a building design project is organized depends on the type of the building, the particular requirements on site, project objective, industry practices. There are no universal structure that suits every building or situation. Instead, the composition and naming of the parts are agreed upon between the client and the design team. This agreement takes project needs, instructions, and legal requirements into account, so each project covers both the building itself and its placement on the land. The breakdown into design fields and project parts is flexible, not fixed. The composition can be adapted to each project specifics and the client's requirements. For instance, some components might be grouped or split based on design goals, procurement methods, or design team's components. Clear structure is important. The aim is to make the documentation logical and easy to understand for anyone using the information. For every part of the building project, the documentation set out the boundaries and scope at the beginning. This explains which section of the building object or area solution relates to. If topic crosses design disciplines like plumbing, information relevant to both architecture and sanitary engineering parts, the documentation indicates how information is divided. For example, details about building automation may be found both in the HVAC section and the dedicated automation part. The overall project information, sometimes called the common part, is produced by the main designer and provides a holistic view of the entire building project. Let's consider the example of exterior space design. This field covers the spatial function and the technical solution for the site as a whole. It defines how the spaces works and the relation between different parts of the external areas. The layout and design and both structure and landscaping, the safety of users and environment sustainability. Graphical documentation is important for external space design. Standard visual representation include the site plan, which shows the position of the buildings, the green spaces, utility network plans, the map of the infrastructure, vertical plans of heights and slope information, and the location of diagrams to illustrate the site connection with the surroundings. These drawings help all users, designers, and clients understand how the various components interact. In summary, the composition of the building design is project adapts to the project needs, with clear parts laid out agreement between the client and the design team. Each part defines its scope, clarifies interdisciplinary relationship, and combines text with the graphical representation to ensure the project documentation is practical, comprehensive, and easy to use. Roads, traffic, and utility networks are key elements when developing and innovating any site. Let's start with the roads and traffic facilities. This includes structured designs for vehicles and pedestrians, such as roads, streets, and parking lots. Traffic management, connections to existing networks, and related structures like bridges, viaducts, tunnels, retaining walls, and so on. Importantly, this also covers restoring pavement that might be affected by other construction works like utility installation. Landscaping is another essential component. It involves planning and maintaining the plant life on the site. This includes deciding which kind of plants should be used, where they should be placed, how will be maintained, and what happens when the plants need to be removed or replaced. Both high and low landscapings are considered, covering things like ground cover and vertical planning. This category also deals with any structures and soil work necessary for plant growth and outline cleaning, and the special maintenance requirement for the upkeep. Outdoor lighting is crucial for both functionality and safety. This part focuses on the designing lighting systems to ensure they are both visually suitable for the area and operate reliable. It covers how the lights turn on and off, as well as how they handle emergency situations. While the design and setup of lighting systems are included here, the actual power supply for lighting falls under different sections specific to electrical networks. Now let's look at the category of external power and gas. The external electrical power network supplies electricity to all buildings and structures in the area. This includes the installation of the cables, connections, and electrical equipment. For gas, the external gas supply network handles the pipelines, fittings, and other parts necessary to deliver heating gas to users outside the building, from distribution lines to consumer connections. Low voltage networks cover the systems that connect different site buildings for communication and security. This includes telecommunication, security systems like access control and video surveillance, and sound systems. These networks are essential for supporting safety and daily operation throughout the site. Heat supply is managed in two main parts: the heat source and the network that distributes the heat. The heat source might be a boiler room or heat pump, whichever generates the heat needed by the site. The heat supply network then circulates the heat, often as hot water or steam, throughout the pipes and valves and all the building that is needed. Finally, the water supply and the drainage handles all the external water and sewer systems. This includes pipes, pumps, stations, and treatment plants for both water and waste. Special infrastructure is included for firefighting water supply, ensuring both public water and sewer connection are managed safely and reliable. Taken together, these categories ensure that the site isn't just built for today, but fully equipped for ongoing uses, maintenance, and future development. Each element, roads, green spaces, lighting, power, gas, and communication, plays a specific role in making the area safe, functional, and sustainable. Comprehensive building design addresses several key fields to ensure that the building is safe and functional and comfortable. The first major area is building volumetric and function. This covers how spaces are organized within the building, how the building connections with the surroundings, and how well they perform both technically and functionally. It also considers the finishing touches and safety features needed to everyone use. Internal architecture and acoustic focus on how rooms are designed and range from layout and furniture selecting to the overall looks and comfort. A critical part of this is acoustics, making sure rooms have good sound isolation from external noise and between different areas inside. This includes controlling both airborne and impact noise, optimizing acoustic quality for the room intended use, and managing the noise generated by the building equipment. Lighting is another crucial design field. Comprehensive lighting installation must cover both everyday and emergency needs. This involves not just the placement of any type of lights, but also how the lights are controlled and switched. Lighting design should meet regulatory requirements, fit the building's looks, and serve practical purpose. It is important to note that the lighting system in design typically bridge the gap between interior design and electrical systems, but they do not include the actual electrical power supply, which is addressed in the separate engineering discipline. Locking system deal with how doors can be securely closed and easily opened, especially in emergencies. This system also needs integrated seamlessly with such technologies such as access control, fire alarms, and intercoms. The focus here is the functional of the locks and mechanism, while the components like hinges and the drop seals are not part of this category. Structural elements of the building must be designed to carry all expected loads and maintain overall stability and rigidity. This part of the process ensures the building remains safe and durable during the lifespan. Fire safety and environment system are also central to comprehensive building design. Fire safety planning covers the section of materials, the layout of the components, and the control areas. It includes systems for smoke detection, automatic fire suppression, and access to the water source for firefighters. These concepts set the basic principle of fire safety principles to apply to all aspects of the building design. Finally, creating a healthy and controlled indoor climate relies on heating, ventilation, and air conditioning, collectively known as HVAC. This technical system requires temperature, air quality, and humidity throughout the building. Integrated heat exchange units, district unit system, and sometimes include providing efficient and consistent comfort for the occupants. In summary, each key field has a specialized role, but together they form a holistic approach to produce design that balance aesthetics, technical requirements, and safety and usability.